Just a brief half-century ago, what you are now seeing would not have been possible, either with or without the magic of the motion picture. It would not have been possible because even in the memory of some of you, production was a slow, painstaking process, slow and not so sure. Then, as the great industrial revolution hit its stride, as a constantly growing population demanded more and more, the real importance of machine tools was realized. Our demand for more and better things gave birth to the mass production assembly line, and a river of goods began to pour forth from the factories of America. Behind this productive capacity are modern machine tools, the master tools of industry. Failure to utilize their cost-reducing and product-improving possibilities is contrary to the American concept of making more goods available to more people at less cost. Many manufacturers have adapted World War II machine tools to a new era of production, and they are finding that such tools are woefully inadequate, that the age of a piece of machinery in years isn't the only way of determining whether or not it is adequate for current production requirements. Product design and specifications, operating costs, including maintenance, the type of equipment used by competition, and the results obtained, space limitations, employee morale and safety, and dozens of other factors are involved in modernization. Many of these factors cannot be anticipated accurately, but one thing is certain. A carefully planned system of maintaining records on machine tool operating efficiency will one day provide you with information vital to your modernization program. When you have all the facts and face them squarely, the problem is going to arise as to what type of new machinery will best fit into the program. Where lathes are concerned, it just seems logical to think about an organization that specializes in lathes, the largest exclusive manufacturer of lathes in the world, the Monarch Machine Tool Company of Sydney, Ohio. For over 45 years, Monarch has operated on one principle, a determination to design and build the finest lathes possible. This singular dedication has brought about many innovations and firsts in lathe production. It has meant painstaking care in every phase of the operation, a constant guard over quality, and a secure confidence in the final product. The trademark Monarch means what it says, leader in the field. Factory officials, buyers, engineers, either seeking advice or interested in observing our manufacturing methods at first hand, are always welcome visitors at the Monarch plant. Design engineering triggers development. This is one of 3 departments strategically located about the plant and staffed with experienced men familiar with every phase of lathe design. From these drawing boards come designs for many outstanding developments in metal turning equipment. In addition to the world's finest engine and toolmakers' lathes are the famed air gauge tracer, a duplicating device of outstanding accuracy, the high production monomatic, the versatile speedomatic, and many others. Walled off in its own world, literally a building within a building, is the air-conditioned Quality Control Center, a compact arrangement of test and experimental facilities. It houses chemical and metallurgical laboratories, a gear control area, and heat treating equipment. The quality of Monarch production depends heavily on the answers supplied by the center's technicians. Guesswork has no place in selecting the raw materials that go into our lathes. The control center makes extensive use of chemistry in analyzing the quality and alloys of the metals used. This knowledge is made possible by an average of 150 analyses conducted weekly by the center's chemical section. Unusual care is taken in drilling samples for chemical inspection. At least one test specimen from every lot of beds is checked. The test chips are taken from deep beneath the surface and are drilled slowly to prevent any overheating that could affect the composition of the metal. No coolant is used as a further precaution against contamination that might give a false reading. The length of time for such a test is never questioned. Accuracy is the first consideration. Weighing the chips on a sensitive chemist's scale is another painstaking step in analysis. A fractional error could mar the entire test. The accuracy of scales and other delicate test instruments is kept constant by the center's controlled temperature and humidity. These small crucibles are used to burn away the filter paper containing metal deposits. The purified deposit is then placed in a desiccator for cooling. This is another guard against contamination, an added assurance the final answer will be correct. Many different types of metals go into a finished Monarch lathe. Steels of various hardness, cast iron, a variety of alloys. Quality Control Center conducts over 40,000 metallurgical tests a year. Here a spot check test is made to determine the presence of nickel in certain alloy steels. The metal precipitate is carefully touched with a chemical solution. A positive or negative reaction will show in a few seconds and indicate any need for a more accurate percentage test. The technicians of Quality Control Center act as a trained detective force. It is their duty to apprehend and arrest substandard materials before they reach the Monarch production floor. Hardness is an important element in many parts of a lathe, particularly in gears, bedways, lead screws, and spindles. Monarch design specifications are extremely rigid on this point. The long life and accuracy of our lathes is made possible by continual hardness tests. This bedway test specimen will undergo more detailed study by microscopic measurement and microphotography. The control center also spot checks hardened surfaces of sleeves, shafts, and innumerable other hardened parts. In addition to hardness, other characteristics of all moving parts subject to constant stress must be determined. A study of the microstructure, now possible with modern instruments, determines the strength and lifespan of a lathe part. The segment to be tested, in this case a gear tooth, is first molded in clear plastic, then polished and etched. This leaves a crystal clear, scratch-free surface, ideal for microphotography. The structure is clearly revealed by this process. These extensive tests add bit by bit to the ultimate goal of Monarch engineers. Lathes, strong and dependable, rugged and yet as accurate as man and instrument can make them. For this purpose, our highly specialized chemical, metallurgical, and experimental heat treat departments are constantly being improved and expanded. Plant officials, men well aware of the importance of combining science with production, find the Quality Control Center a rapid and dependable checkpoint on production activities. Daily graphs, charts, and test samples give them fingertip control over the high standards that are a constant requirement. The center's technicians, with a vast file of facts on hand, are able to provide the answers to today's problems as well as many that may arise in the future. Control of production accuracy is the function of the gauge rooms. This department standardizes and maintains tolerances for all machining and assembly operations. Parts such as this piece are brought to the dust-free, constant temperature gauge rooms to ensure accurate measurement. Also stored here are the thousands of standard gauges in constant daily use throughout the factory. Master gauge blocks are used to set up this specially designed Monarch checking device. Highly sensitive, it inspects lead and cross-feed screws to be sure that they are accurate within 2 ten-thousandths of an inch per foot, non-accumulative. Precise optical instruments are a part of this checker for our large lathe lead screws. Maximum tolerance is 4/10 in any 4 inches. Such rigid requirements are routine in Monarch inspection and make possible the highest precision standards in the industry. Technicians from the master gauge room are responsible for a constant check on the many gauges used on the production floor. Here, a master disc, used for setting snap gauges, is being compared against a known standard, Johansson gauge blocks. Double checking has become an accepted practice at Monarch. Magnified many times, a section of a cross-feed screw shows up on the screen of a comparator. Depth of thread and tooth profile are checked for dimensional accuracy. This series of checks dovetails to form a composite report on the accuracy of Monarch lathe parts. Actual lathe production begins here at the far end of the plant. These castings, wheeled in from the storage yard, are 10-inch precision lathe beds. In a few minutes, shot blasting removes all rust, corrosion, and scale. Paint is always applied without delay to the perfectly clean surface. Safeguarded by a curtain of running water, a painter gives this headstock its first prime coat. A red primer is used on exteriors while the interiors receive the standard white. All component castings are given similar prime coats. This includes tailstocks, aprons, covers, and various levers and handles. This is how Monarch flame hardens its bedways. Developed back in 1936, flame hardening assures lifelong bedway accuracy to the users of over 25,000 Monarch lathes. Both flat and V surfaces are hardened simultaneously to the depth of 1/8 inch plus, and with a Shore scleroscope reading of 70 to 72. Flame hardening is an absolute must if the intrinsic trueness of carriage and tailstock bedways are to be maintained. This method produces ways as hard as hardened steel, plus perfect metallurgical bond with a high-strength chromium alloy beds. Flame hardening cast iron results in a minimum of vibration, hence a maximum of accuracy during the entire life of the lathe. Grinding the bedways to 5/10 overall obsoletes the old process of hand scraping. The hardened paralytic cast iron produces a perfect bearing surface with millions of microscopic reservoirs for holding way surface lubricant. Gears, gears, gears. Lathes are loaded with them. Many types, many sizes, for many uses. They're so vital we make our own, thereby assuring consistent high quality and a constant supply when needed. Gear tooth contours are either electric furnace hardened and ground, or shaved and flame hardened. Our production planning brings the machine to the work. The spindle machining department is a typical example. Where tools were formerly grouped by types and functions, they are now arranged so each department can do all its own machining operations. It requires more tools, yes, but adds another step toward quality and smoother flowing production. Only grinding assures the close, exact fit specified for all spindle splines, one of the many extras in every Monarch lathe. The headstock spindle, literally the heart of a lathe, goes through 55 exacting tolerance tests before it reaches the assembly floor. Some of these are bearings run out, limit 1/10. Spindle nose run out, 1/10 limit and a 100% bearing. Bearing sizes limits to 2/10. You will note that each indicator snap gauge is set to its own master. In an especially severe test, the run-out limit on a test bar is checked at the extreme point of 14 inches from the spindle nose. Even at this critical extension, it must be true within 2/10,000ths. One of the most carefully constructed Monarch products is the famed air gauge tracer. These precise duplicating devices are assembled in a section of the plant often called the 10th room, a reference to the extreme tolerances specified for the finished product. Use of the air gauge tracer adds almost phenomenal productiveness to many of our lathes. These valve stem ODs and bearing diameters are ground to within 1/2 and must show a 2 to 2.5 micro-inch finish. "3/16" portholes are ground in the valve sleeves with a plus or minus tolerance of only 1/2. The finished work shows only 25 millionths out of round, barely measurable. This is a routine tolerance on this grinding operation. To be equally accurate, the valve sleeve inner diameter is honed to the same exact standards. The high efficiency record of the air gauge tracer is due mainly to the exacting standards that are maintained in construction. This ID shows only a 40 millionths variation. Each completed air gauge tracer mechanism goes through a test run to check accuracy against a master gauge. Here it follows a taper and moves smoothly onto a straight diameter. The mechanism settles and holds within 1/10, our design specification limit. Another exclusive and unusual use of flame hardening. Here you see the process applied to long lead screws, which are used to provide feed movement on certain of our lathes. Induction hardening is used in our 10-inch Model EE lead screws and all cross-feed and compound screws. Afterwards, they are precision ground. Gears, too, are flame hardened. The single-tooth progressive method is used. We also harden racks, clutch teeth, cam surfaces, shifter forks, and many other parts. Spindles are heat-treated in an accurately controlled electric furnace at temperatures ranging from 1400 to 1600 degrees. Special precautions are taken to prevent oxidation and to maintain the same exact temperature from top to bottom. Skilled operators keep a watchful eye on the time and temperature gauges to bring the spindles to the specified hardness. As you watch these spindles move to the oil quench, ask yourself, are the lathes in my shop built like this? Will the new ones I plan to have be as well constructed as these? There is one easy answer: Monarch. All gears go through intensive inspections in the Quality Control Center. An exacting inspection is the involute check. This machine checks the profile of gear teeth. By measuring the mating surfaces, it finds that the deviation from true involute profile holds within 3/10,000ths. Smooth power transmission in a modern high-speed lathe is dependent on many varied types of gears. Gear manufacture calls for extreme accuracy. This is costly and takes time, but the final result of vibration-free performance is worth the effort. The helix angle of the gear is checked by a helical lead measuring machine. In this severe test, the error must not exceed 2/10,000ths. As many as 14 helical gears are used in the headstocks of some Monarch models, so the importance of complete accuracy in this test is obvious. One of the recognized master gauges of the trade, a super micrometer, in the master gauge room is used here to check the gauges that check the gears. Another example of step-by-step accuracy that will assure top gear performance. An additional precise production operation. This jig grinder is used to grind the locating holes in all Monarch turret blocks. The accuracy maintained for this routine operation is typical of the Monarch method, a method that tolerates only the best. In this case, the tolerance is only 2/10,000ths of an inch. All Monarch setting dials are large and easy to read, with all lines precision scribed. Only the numbers are rolled on. From the storage yards, we have progressed by straight line workflow to the final lathe assembly. One of the busiest sections of the assembly floor is reserved for the 10-inch Model EE lathe. Over 6,000 of these precision machines have gone into factories all over the world. Headstocks are carefully scraped and fitted to the bedways. Then comes a severe aligning bar test, taken 12 inches out from the spindle nose. In or out error must not exceed 3/10,000ths. Up or down error is held within 5/10,000ths. Tailstocks are fitted with equal care and checked against the aligning bar. Alignment with the headstock must be true within a limit of 1/1000th. Located 1 story below the assembly floor is a unique power distribution center. This huge panel directs AC current at any voltage, phase and cycle, and DC current at any voltage to 100 assembly stations above. Electricians insert the power jacks in much the same manner as on a telephone switchboard. Each lathe assembly station has a numbered plug-in receptacle corresponding to a similar number on the distribution panel. An operator can run an immediate power test on a machine regardless of the type of current required. An all-over check is made on an assembled lathe which shows a tendency toward vibration. A sensitive vibration discrimination instrument is used in locating the source and making the correction. Now's the time for painting, that final going away touch. Standard finish is the conventional machine tool gray. Securely crated and tagged, finished Monarch lathes move from the trucking platforms or railroad siding, bound for destinations across the country or across the world. The ever-expanding demands of the machine tool industry have created another responsibility, working for the future through experimental engineering and new development. Some years ago, Monarch pioneered in this field. Today, this activity is housed in a separate building, staffed with specialized technicians and fully equipped to carry on our development projects. This experimental hydraulic pump, for example, is being checked with a special gauge to be sure the accuracy is within the required tolerance. The gauging paper being used here is just 4/10,000ths of an inch thick. This unusual hydraulic valve body is part of an idea that has passed beyond the blueprint stage. Such operations as this are entrusted only to expert craftsmen. In order to provide a well-rounded research program, the personnel of new development is directed by trained mechanical, electrical, and hydraulic engineers, men who have shown a definite aptitude for experimental work. The rapidly expanding field of electronics plays an important part in the development of experimental designs. Here, various checks are made on a recently developed motor, an advanced model that may improve lathe operation. This cathode ray oscillograph of latest design is used principally to study the starting characteristics of motors. The work in new development is more than experimental. It also serves as a testing laboratory. Electrical equipment is given a thorough check for wearing qualities, both electrical and mechanical. For example, here a study is being made on the lapse time of a relay to determine if it is suitable for our use. In addition to relays, limit switches, resistors, capacitors, electronic tubes, and other parts are continuously life-tested. The object is a day-to-day search for the best equipment available. Exacting time and temperature tests are made on all types of motors. All electrical equipment is expected to meet the same rigid standards we apply to our own production. This assurance adds to our complete confidence in the quality of a finished Monarch machine. It requires more than good design, good materials, good workmanship to build better lathes. Among other things, it requires that we determine the machinability of new metals, understand cutting tool temperatures and tool life, understand how to overcome self-induced vibrations that affect accuracy, determine the importance of shear stresses and strains, conduct chip studies, and delve into basic research on a multitude of related problems. It is here that the accuracy of the finished product is predicted, a prediction made certain by constant research into every phase of metal working. In the last few years alone, we have conducted thousands of tests on 25 different subjects related to machinability. This constant research and testing has a twofold purpose. We are able to make constant improvements in lathe design, and at the same time, we are able to offer our customers accurate and detailed performance data on any Monarch model. Models such as this 10-inch EE toolmaker's lathe, the 10-inch EE manufacturing lathe, the 13-inch EE precision lathe, the Series 60 engine lathe, the Series 61 toolmaker's lathe, the heavy-duty lathe, the heavy-duty roll turner, the Model 20 monomatic, the Speedomatic, the Series 60 with air gauge tracer, the heavy-duty lathe with Monarch Keller controls, the Shape Master engraver. Watch a Monarch operate. Visualize machines like this high-production monomatic in your plant. Here's a lathe that often pays for itself in less than a year, that saves thousands of dollars yearly on tooling costs, that sets up in minutes instead of days, that eliminates subsequent grinding entirely or reduces the grinding time by half. Or think what can be done on this small, versatile precision lathe. The ashtray is rotating at 4,000 RPM. The single cutting tool, air gauge tracer controlled, imparts a smooth contour, accurate to 1/1000th of an inch. Through such accuracy and versatility, machine tools like Monarch lathes have become the foundation of modern civilization. You'll find the selection of a Monarch a definite turning point toward better products and more economical production.